Welcome to the chapter 6.1 notes. Go ahead, pause the video and do these couple warm-up problems quick. Just solving for x, basic algebra stuff. Shouldn't be too complicated. So when you're done, unpause and see how you did. So I'm going to start by subtracting 2x and subtracting 7 from both sides. That'll give me 3x equals negative 12. Divide both sides by 3 to get x equals negative 4 for that first problem. In the second problem, I need to get everything on one side like this, and then I can try to factor it, or I can use my quadratic formula. It's kind of up to you. This one does factor. I know I'd have a 2x and an x, then I need to have a 5 and a 1 to make that 5. It's going to have to be negative. I'm going to put the negative in front of the 5 so that when I FOIL, the outside gives me the negative 10x plus 1x gives me that negative 9x. So then either 2x plus 1 equals 0 or x minus 5 equals 0, which means that 2x equals negative 1. So x equals negative 1/2, or x equals 5 if I added 5 to both sides. Okay, for today, for this lesson in Trig, what we're going to be doing is solving equations. Okay, it's basic algebra rules, but then there'll be one step further in pretty much everything. So where this comes up is going to be in situations like this, where you're not very consistently going to be having to figure out the height of a human cannonball, but it's given by this general equation where this is supposed to be multiplied by sine theta. So the height after time t still has a theta involved, where theta is a different variable. This would be adjusting the angle that the cannon shoots the person out at. All right, so you could have different angles. You could have a really steep angle, a shallow angle, kind of whatever you want. But we're actually going to go ahead and solve these. I think every example in today's notes has a restriction on what x can be. I'll talk more about that kind of as we go. So to figure these things out, treat sine x. So treat trig functions like its own variable first. All right. So even though it says sine x, in algebra 1, I would be able to give you an equation like this, and you'd be able to solve for x. That's what you're going to do, except for now instead of solving for x, you just solved for sine of x. So you have another step. So this would be add 1 to both sides. So 2 times sine of x is equal to 1. Now divide both sides by 2 to get sine of x equals 1/2. Remember, sine of x is not sine times x. Sine of x is its own thing. That's all in one group. So I don't divide by sine. I can't divide by sine. What I'm going to do is take sine inverse of both sides. Sine inverse of sine leaves just x on the left, and then sine inverse of 1/2. This is where you actually have to kind of think a little bit because of this restriction right here. I know sine is positive in these two quadrants. Okay, everything is positive here. Sine's positive there. So I've got two possible values that this could be. I know that in our first quadrant, we know that x is going to be 30. We're in degrees. That's why I know it's 30 and not pi over 6. Or if I put this in quadrant 2, that would be 180 minus those 30 degrees would be 150 degrees. So those are my two possible answers. Now, if I didn't have a restriction here, where I just said solve the algebraic equation for x, you would have these two values, but you would want to write it as 30 plus 360k or 150 plus 360k, where k is just some number. That's just counting the number of times you went all the way around the circle. So if you went just 30 degrees, that's k equals 0. If you did k equals 1, that's all the way around and then another 30, or all the way around twice and another 30. That's all that k is doing. 360 is just how many degrees in one full rotation. Okay, same thing here. We've got a restriction on theta. So if I want to figure out what theta is, I first need to divide both sides by 2 to get cosine of theta equals 1/2. Then we take cosine inverse of both sides. That leaves theta equals cosine inverse of 1/2. Well, cosine of 1/2, cosine inverse of 1/2. Cosine of theta equaling 1/2 tells me that cosine is positive, which happens in these two quadrants. So I'm going to have two possible values. It's going to be theta equals 60 degrees or theta equals 300 degrees. Okay, 60 degrees this way or 60 degrees in the negative direction would give me a positive 300-degree rotation. Number 2 looks more complicated, but again, treat this as just like 2x plus square root of 3 equals 0. You start by subtracting square root of 3 from both sides. Then you divide both sides by 2. Now, since I've got sine of theta equals something, in order to undo the sine, I take sine inverse of both sides, and that's of the entire fraction. So if I think of my unit circle, sine of theta was negative, so it's going to be down in these quadrants, 3 and 4. We're looking at these angles right there. So if I think of my reference angle, okay, remember reference angle is going to be up in quadrant 1. The reference angle will tell us how much we're going to have to add to 180 or subtract from 360. If I just look at square root of 3 over 2, I know that that's going to be, since we're in degrees, that is going to be 60 degrees. But theta does not equal 60 degrees. That's the reference angle. Okay, we start here, we go all the way around, that's 180 plus that reference angle, which is 60. So that'd be 240 degrees. Or if I had started at the beginning, I could go all the way around, or I could just go back 60. 360 minus 60 tells us 300 degrees. So from the beginning to that part written in green is all Algebra 1 steps. The sine inverse of both sides, we've done that in geometry. We've done that in this class. This final step is recognizing that you have multiple possible answers. We would have an infinite amount of answers if it didn't specify that theta is between 0 and 360 inclusive. Okay, if that was not there, I would have 240 plus 360k and 300 plus 360k. Now we're going to change to radians. The process is the exact same thing. In number 3, I'm just counting how many sine t's I have, like 5x and 3x would together be common terms, would be like terms. So I'm going to start by, you can do this a few different ways. I'm going to start by subtracting 5 sine t from both sides. That leaves positive square root of 3 equals negative 2 sine of t. If you wanted to, you could bring the 3 sine t over and set it equal to 0. That would work fine. You just have one more step. So now I divide both sides by negative 2. So I have negative square root of 3 over 2. Remember, if you divide by a negative, you can just put the negative in the top part. That wouldn't change anything. And this equals sine of t. Okay, square root of 3 over 2. We just did this one, right? It's a negative, so it's down here. And we said before it was 60 degrees, but now we have to be in radians. So when I take sine inverse of both sides, and notice I'm putting sine inverse in the front. Don't do this. That doesn't do anything because sine inverse is its own function. That tells me that t is going to equal 4 pi over 3, or t is going to equal 5 pi over 3. The reason I get this is, again, think of our reference angles. If I'm looking at a 60-degree angle up there, that in radians is going to be pi over 3. If I go from here around to there, that's 1 pi plus a reference angle of pi over 3. That gives me 4 pi over 3. If I had started here and gone back pi over 3, That's 2 pi minus pi over 3, which would be 5 pi over 3. All right, for number 4, subtract 4 from both sides. You get 3 sine t is equal to 0. Sine of t is its own thing, so I can divide by 3. I can't divide by sine t. You're never going to want to divide by sine t when you're solving for these things, because sine of t could equal 0, and if you divide by 0, you're breaking a whole bunch of rules. I'm going to take sine inverse of 0. Now I've got to be careful. This one actually has 3 answers. T could equal 0, t could equal pi, or t can equal 2 pi. And this is all because of the restrictions. It can be 0 and it can be 2 pi because of the less than or equal to. If it did not have one or both of those or equal to's, you would have different answers here. But sine of t equals 0 when you have 0 radians, pi radians, 2 pi radians. That's our unit circle, okay? Anytime you're at this spot or that spot. So just like with the degrees, if you don't have a restriction here, you would have written this as t is equal to 0 plus, instead of 360, since it's in radians, one rotation is 2 pi k plus, or not plus, sorry, t equals pi plus 2 pi k, and then you won't have to write t equals 2 pi plus 2 pi k because that's part of this one. If you wanted to be real fancy, you could say in this case t is equal to 0 plus pi k, or just pi k. Okay, if k equals 0, you get this. K equals 1, k equals 2, k equals 3, you get back to just pi. All right? But you don't need that for this one because of the restriction. For number 5, you're going to have to use your calculator and a little bit of reasoning. All right, so I'm going to start by subtracting 3 cosine from both sides, 3 cosine of theta. And then I'm also going to add 1 to both sides, which will leave me with cosine theta is equal to 5. If I want to know what theta is, that's the cosine inverse of 5. You're going to have no solution as your answer. If I could spell, that'd be fantastic. It says use your calculator, and your calculator is never going to say no solution. First, make sure you are in degree mode. If you're in degree mode and then you hit cosine inverse of 5, your calculator is going to say error domain and then give you the option of quitting or going to. You have a calculator error because cosine of theta is bounded between 1 and -1. So cosine of theta cannot equal 5. That's why we get no solution. It's not possible. All right, number 6. We are in radians this time, so if you're going to do anything with your calculator, you got to make sure you go back to radians mode. This thing factors. Treat this like 2x squared minus 9x equals 5. That means I would actually just have this right here. This is exactly what we did in the warm-up. Okay, the warm-up, we said it was 2x plus 1 x minus 5 equals 0. So what we have here is actually going to be 2 cosine of t plus 1 times cosine of t minus 5 equals 0. Instead of writing x, we have cosine of t. So now either 2 cosine t plus 1 equals 0, or cosine of t minus 5 equals 0. This is the same algebraic steps. We have two things multiplied together to equal 0, which we do. That's what those sets of parentheses tell us. One of the two things have to be 0. So I'm going to start with the left one. If I subtract 1, you have 2 cosine of t is equal to -1. So cosine of t is equal to -1/2 when you divide by 2 on both sides. So then you take cosine inverse of -1/2, and then cosine is going to be negative in 2 quadrants. Okay, these 2 quadrants right there, quadrant 2 and quadrant 3. So in order for it to be negative 1/2, t has to equal 2 pi over 3, or t is equal to 4 pi over 3. We're in radians, that's why I'm using radian measurement. And I know that that's going to be the case because in my reference angle of pi over 3 tells me cosine would be 1/2. Cosine of pi over 3 is 1/2. But I took away from pi over 3. That's my reference angle. That's how I get 2 pi over 3. Or I added another pi over 3. That's how I get 4 pi over 3. Now I also have to solve this other one, which would be cosine of t equals 5. If I try to do this, I'm going to get the same error that I got before. So this one has no solution, meaning that thing can't ever equal 0. So this is my answer. You're not going to box no solution. No solution just tells me that this factor, cosine of t minus 5, cannot equal 0. So 2 cosine of t plus 1 had to equal 0. So t is one of those two values. For this next one, we're going to use our quadratic formula. Remember, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that gives you x. I don't have an x here, but I'm going to say this is basically the exact same thing as 2x squared minus 4x plus 1 equals 0. The number that goes in front, or your coefficients, are what goes into this. That solves for x in the quadratic formula. In this case, our x is cosine of theta, not cosine squared of theta, because that's our x squared. So what I actually have is cosine of theta is going to equal the opposite of b, which is a positive 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. So when I continue this process, my left side I'm just going to keep as cosine until I get this fraction simplified as much as I can, and then I have to go from there. So this is equal to 4 plus or minus the square root of 16 minus 8 all over 4. It's tempting to want to cancel these 4's out. You cannot do that because of that plus sign. All right, so we got to do a little bit more work. Oops. Don't want to write in a highlighter. Cosine of theta is going to equal to 4 plus or minus the square root of 8 over 4 if you take 16 minus 8. Now you need to simplify that square root. So that square root is the same thing as 2 square root of 2 over 4. The reason I know it's 2 square root of 2, if you do your factor tree with 8, it's 4 times 2. Square root of 4 breaks out to a positive 2. Now you can simplify, but you have to do all 3 terms at once. So the only factor that all 3 things have is a 2. So this leaves us with 2 square root of 2 over 2. Divide the 4 by 2, divide 2 square root of 2 by 2, and divide 4 by 2 again. So you've got options. You've got cosine of theta equals 2 plus the square root of 2 over 2, or cosine of theta equals 2 minus the square root of 2 over 2. Now this is where it kind of gets a little bit tricky depending on how you have your calculator set up. Make sure you're in degree mode because it says we are in degrees and we're rounding to the nearest tenth of a degree. But right now I should be able to eliminate one of these two possibilities. And the possibility that I can eliminate is this top one. I can eliminate this top one because 2 plus square root of 2 over 2 is greater than 1. And I know that cosine is bounded between negative 1 and positive 1. So that one is not in range. It's too big. If you don't see that, hopefully you do, because 2 over 2 would be 1 plus something would be bigger. You can plug that into your calculator. 2 plus the square root of 2 over 2. Sorry, I got my calculator off to the side here, and I forgot to clear after that last problem. That would tell you cosine is 1.707106781. Don't round until the very end. I don't want to write all that. I can identify that this is bigger than 1. So that means this thing has to be true. So I need cosine inverse of that thing. you can plug that straight into your calculator, but you're going to have to be careful about it. So if I hit cosine, I'm going to put an extra parenthesis, 2 minus square root of 2. Put a second parenthesis, so I know I have one set of parentheses already. Divide by 2 and close the initial parentheses. That's going to tell me an answer. Or what you can do is calculate what this thing is. So 2 minus square root of 2 in your calculator, then hit divide by 2, which is 0.29289322188. I would want you to use that entire value. This has two values. Okay, two possible values, just like all the other ones. It's going to be very easy to go through all of this work and get to here, plug it in your calculator, and be done. But what the calculator is going to tell you is a reference angle. So I have theta equals 72 point, it says 968755154 in my calculator. That is one of the possible values. I have two possible values because of our restrictions. Because cosine is positive in two different quadrants. Cosine is negative in two different quadrants. I know this is a positive value because 2 is bigger than the square root of 2. So in order for cosine to be positive, it's got to be in quadrant 1 or quadrant 2. We found the reference angle, which is in quadrant 1, so that's one of our answers. Now to find this reference, or the angle down here in quadrant 4, I'm going to take 360 degrees minus that reference angle. So if I do that, I get 287.013, oh, I did that backwards, 0.31. Let me restate all of that, because starting in the middle of the number, I'm stumbling over myself. 287.0312, and there's some other stuff. That'd be still an estimation. Now, the question actually says to round to the nearest tenth of a degree. So I'm going to come back and actually have theta equals 72.96 would be actually 73.0 degrees, or theta equals 287.0 degrees. Even though they are 0.0, since we are rounded to the nearest tenth, you need to have a tenth place. All right. So rounded to the nearest tenth, those would be your answers. All right. There's your homework assignment. Give those a shot. If you have any questions, just let me know, and I will see you guys in the future. Hope you all have a great day.